Okay, here we are with lesson 7.2.1. How can I find the equation? This is something we've been talking about for quite some time. Then the first problem here, 7-79. Find the equation of the line in y equals mx plus b form with a slope of 3 that passes through the point 519. So we have a point and we have a slope. I know we've talked about using a calculator to solve with the stat function. However, that requires that we know 2 points. We currently do not know that. So we know 1 point, which is an x and a y value, along with the slope of 3. So we can take our equation y equals mx plus b and plug in everything we know and see that we have 19 for y, 3 for m, 5 for x, and we do not know the initial value b. And then we would just have to solve this equation for b. So we would multiply these two together first. 3 times 5 is 15. Oops, plus b. And then subtract 15 from both sides to get your b value of 4. Now the problem is asking us to find the equation. So we have to go back and say y equals 3x, that's our slope, plus 4. Now, there are other ways to find that initial value. You could also use a table. So if we were to use a table, we know that our fifth number is 19. We know that our growth is 3. So if we're going backwards in our table, we would subtract 3 to get the previous number, which would be 16, 13, 10, 7, and our 0 number is 4. So that would be an alternative method, opposed to the algebraic method to use a table. However, that's not what we're going to talk about today. We're going to talk about exponentials, a times b to the x form. Okay, that's what this chapter is all about. That's what we're working on. And here we see, while trying to find the equation for the graph in part C of problem 59, show again at the right, arrow stated, I think a must be 7 because the y-intercept is 7. That's true. The y-intercept is the initial value. They mean the same thing. They are one and the same. However, we do not know our multiplier because we have a first number, a second number, and the third number is the one we know. So we would have to think of something we have to multiply 7 by 3 different times to get 56. Now, these are going to detail the steps algebraically. So if you would like to know the steps algebraically, you can go ahead and follow your book as it works. However, we have been working with using the calculator, and that is a valid method. So remember, the steps to do that should be written in your toolkit. They're still written on the board right next to the Promethean board right now. Stat, edit, and in L1 we're going to type our x values. 0 and 3 are our x values from this problem. 0, 7, and 3, 56. And then we have 7 for our first y value, 56 for our second y value. Okay? Stat, calculate, and this is an exponential function, so we're going to choose exponential regression. Enter, enter, and we get our equation of y equals 7 times 2 to the x. A, b to the x form. This is not linear, these are exponential. Okay? 81. Errol and Sandy's method for 80. Find the equation. Exponential function as to 0. Pass through the point 0.5. 320. So again, we have 2 points. You can go algebraically, the way the book detailed it, or we can use the calculator, which obviously is the preferred method if you remember how to do it. It's a perfectly legitimate method. You're not cheating. 5 and 320 are our 2 y values this time. So we're going to go stat, calculate, and this is exponential again. Enter. And we get our equation of 5 times 4 to the x. Now you can check yourself by going back into your calculator, going to y equals, typing your equation 5, 4, caret key, x power, go to the table and verify that your point 320 is in there. That would be just a quick check for that type of problem. Next, new notation for roots. So you can kind of read down through this. Talks about how to convert roots, which is what we're calling this, better known as radical form of a number. And we're talking about converting it to exponential form. So let me give you just a little trick here that I typically show students. Let's see here, insert. Okay. What we always say is we follow this, which kind of models what they just showed you. That's a flower, and this is called flower power. Ha! Even I'm too young to know what that is. However, these are the roots, and the key idea here is they are on the bottom. Okay? Typically we call this the stem, and in this situation we can refer to it as the base. So that stays the same. And then this part here would be the flower. And here we're talking that means power. So if we have a problem similar to the one here, where we're trying to take a root and convert it to exponents, we have the cube root of 17. So converting that to exponential form will give us 17 to the 1/3. Now, why does that happen? The 3 is the root. It's the third root, the cube root. And the root goes on the bottom of the fraction, just like the roots are on the bottom of the flower. The power, the 1, 17 to the first power, goes on top. The base stays the same. Okay? The other thing that I'll do for students is I'll draw a diagram such as this. So all you have to do is match up your shapes and where they go. This can go both ways. Okay, and what this would look like in radical form would be this. Okay, everybody played that game Concentration when you were a little kid, and the board was like slowly rising, slowly rising, slowly rising, and you were trying to get all the shapes into the right holes. Well, you looked at the shape, you plugged in the right hole. Same idea. Okay, if I give you a problem, use this. All right, let's say we have 6 to the 2/3. If I'm converting that here, the 6 stays the same. The 6 goes in the square. All right, so that's what goes inside the radical, 6. Okay, the 3 is on the bottom. That's the circle. The circle goes here. That's the 3. The 2 is on top. That's the triangle. Triangle goes here. And that's how that works. And it can go both ways. So use that idea to try each of these problems on your own. If the sub pushes, if you push pause right now, you can try them, and then when you come back, the answers will be live. And if you watched it straight through, well then I guess you just got all the answers popped up right in front of you. If you have questions, take a moment to talk to your group, talk to your partners about it, and bring them along to class if they can't be answered. There's a little bit more reading here in your book that you could look at. If you have other questions, then we'll go over this more tomorrow. Same idea here with fractional exponents. And the whole idea, the premise of this is that you can do more of these in your head. If you're concerned about your mental math skills, again, that's not something that is one of my concerns. We do talk a little bit here about no real solution. That's a topic that will come up later in the course. We won't get too deep into it right now because you're still under the presumption that you cannot take the square root of a negative number, which is completely false. It just does not yield a real solution. 85, recall we investigated y equals b to the x. Okay, we had this. Okay, if it was 2 to the x, and then we flipped it to a negative 2. And we said it's actually impossible to graph that accurately because a negative 2 to the first is a negative 2. A negative 2 squared is a 4. And then a negative 2 to the third is a negative 8. So it actually keeps flipping back and forth across the x-axis, making it not a function that we can graph. And that's all for that lesson. Have a good day.